Our topic for today just is the design process. How do I turn my idea into a product for sale on a shelf somewhere? That's the big topic. I don't know if you want to make a few opening comments about that. We have a few talking points that we've queued up, but I'll let you
Sure.
dive in for the moment.
I think the biggest thing is people need to come into it with a plan. They need to understand what the process is and know at least the major steps that are involved in the process, and then come into it with a plan for how to approach and complete those steps. A lack of plan leads to additional costs and time wasted. Sometimes people will come in and they just won't have a coherent idea of what they're trying to do, who their market is, who they're trying to sell to, those types of things. And inevitably, design work can happen, but it certainly is much more efficient and much more cost effective to have a plan from the idea to the final product.
Yeah. And so if somebody does approach you, you can give them the help with getting that initial plan formulated so that they don't
Absolutely.
waste. In a way, you would say, gosh, if they want to waste time, that's just more billable hours. But you don't view it that way. You view it as we need to get from idea to prototype as quick as possible. That's an overarching philosophy within the company, correct?
Absolutely. I am happy to have fewer billable hours and more successful products than the opposite, because successful products, successful projects will lead to more products and projects. Operating efficiently and helping companies and people turn their ideas into successful products as quickly as possible is our goal.
Okay. So I guess one of the first steps is just defining the requirements. What are some of the ideas around defining the requirements of the product? What does that look like?
The requirements of the product, in my experience, most often people come with a core idea. So there's a problem they have identified somewhere with something that they're familiar with, and they have conceived a solution to what that problem is. And most often, people have a pretty good idea of what that core requirement is. So they want a widget that solves a particular problem. Where oftentimes it helps to work through and discuss is the tangential requirements beyond that initial core requirement. These are things like user interface. How are users going to interact with this product or device? Things like support for manufacturing. How are you going to build it? That's something that you want to think about ahead of time and make sure that you don't end up with a solution that costs a ridiculous amount of money to manufacture because no thought went into what that manufacturing process was going to be. You think about things like power usage, connectivity. Another part of the requirements is identifying what the future might hold. Oftentimes people have a core idea. Frequently, they even have some idea of what the future is going to be. We want to talk about that before we even design the first product, because there are things that you can do in that design process that will facilitate more easily adding additional features or additional modes of operation or whatever it might be. And so we want to understand that up front and make sure that when we take an idea and turn it into a set of engineering requirements, that we capture not just how to execute that particular idea, but how to do it cost effectively or as cost effectively as possible, how to support users and make it as user friendly as possible, how to support future development, a roadmap of additional features or additional products and how they might all work together. So figuring out what those requirements are initially is a key step and something we always like to start with.
Yeah, yeah, that makes sense. So you would want to give some thought to future product roadmap at the beginning. Let that
Absolutely.
inform.
It's something that we can help clients work through as well. We have a lot of experience working with clients over the years and developing a wide range of products. And so we can anticipate what may be a follow on variant, a premium version, or a stripped down low cost version. There's multiple ways to approach, and different problems and need different types of solutions. As just as an example, unrelated to us, obviously, is Tesla. When they started making electric vehicles, they started with the most premium one. They started with the Tesla Roadster. And that was because Elon Musk knew that there was some technological hurdles and some other things that they needed to overcome and that would make the product very expensive. And so by starting with a premium product, even though the market for it was smaller, he knew that they could solve those problems with that and then take what they had learned from that and figure out how to do it at a lower cost and provide a more accessible product. Certainly, that is just as viable of an approach as building a low cost initial product and then adding features and a premium one afterwards. It just depends on what the application actually is and the product that you're building. So that's part of capturing those requirements and working through that, what that future might look like to
Mhm.
figure out what is the best approach to take.
You're saying the product roadmap could start out with a premium one first, and then we're going to do lower cost, more stripped down ones later. Or it could be another angle is we're going to start out with a bare bones product, and then we're going to think in terms of later on, we're going to have these premium products. Those are the fork in the road that you may come to during your initial discussions about what's the product roadmap going to be. So it just depends.
Absolutely.
If you're making a car, you're right. You do want to start out with something very premium so you can work at it. But if you're starting out with something else that's not as complicated as a car, then yeah, maybe you start at something less premium and then figure out ways to make a more premium version later on. So you've defined all your use cases, environments, constraints, cost targets, size, power, durability. The next thing is feasibility. We got to make sure that what we've planned can actually happen. And so the proof of concept is how do we get from that to building a product?
Yeah, feasibility is certainly important because, again, most often people have a new idea to approach a particular problem, and the product is almost certain to fail if whatever that proposed solution is doesn't actually solve the problem. So, one of the first things we tackle is a proof of concept of the core concept that product is built around. The proof of concept may not be battery powered, even though the end product should be. It may not connect to the cloud, even though the end product is going to connect to the cloud. It may be bigger than the final product. It certainly will be in different packaging or something like that. But the idea is to develop an iteration of the prototype that will test the core concept at the heart of whatever the product is and validate that it will solve the core problem that it needs to solve. For instance, if I want to build a pet tracking device, so this is something that my dog is going to wear around his neck on his collar, and I will have a handheld device that can track it. So if he gets lost, I can track him down. There are a lot of pieces of that, but the core functionality that we need to confirm is, can I have a handheld device that tracks a remote device? And so a proof of concept of that would be something that involves a couple of radio parts and some firmware that would accomplish that core task of tracking this remote tag. Maybe they wouldn't be battery powered. It certainly might not be the size of something that you would put onto your pet. It wouldn't be in the packaging or anything like that, but it would test that core function, that core feature to make sure that, yes, we can make it work. And it even works if he's on the other side of the block wall or other types of things we would want to test to ensure that core problem can be solved. And so that's really the first feasibility test, is in that proof of concept. The next step is to take that and then start adding other aspects that will be part of the finished product. And we typically try to approach it by addressing the highest risk things first. We try and do an analysis and look at what the features are. Maybe something like, if in my pet tracker device, range is an identified risk factor. And so we would work to build, in addition to a proof of concept to show that will just work, we would also try and figure out, okay, what is the range on this? If it's only good for 20 feet, that's probably not as helpful as 200 feet. And so figuring out the range might mean a design iteration. It might mean that we start with something, review what's out there, look at the radio parts that are available, and we select something based on that. But then testing, it may not be suitable, or may not give us the range that we want. And so then we look at it and try and figure out, okay, what do we do to increase the range? Maybe it needs an additional amplifier on part of the circuit. Maybe it needs a different radio part. Maybe it needs a bigger battery, whatever it might be. We work through that to try and figure out how are we going to meet this range requirement. And honestly, as part of that, there is even a point where you look at trade-offs. When you talk about requirements, many of the thresholds and things like that are somewhat arbitrary. I can say I want a 200-foot range, but if I can really only get a 190-foot range, is that the end of the world? Certainly, if it's 20 feet or 200 feet, that's a problem. But if we can get 190 feet and to get to a 200-foot range means a full redesign, bigger battery, and a bunch of other things, maybe that's not worth the trade-off. And so that's another part of the feasibility is starting to drill down on those trade-offs and figure out what is the optimal combination of features, functions, and design thresholds to get a finished product that is most useful for a user. And by most useful, it doesn't just mean the functionality. It also includes things like cost and just general usability. Because you could build something that works, again, works great, and maybe you could build something that has 1,000-foot range, but if it costs $10,000 for each one, there's not really a market for that. And figuring out where is that balance between, in this case, something like range and cost and weights and other things like that is part of that development process and part of nailing down what the path is that you want the entire product to take.
Yeah. So once you get through that phase, you've validated your idea, figured out some trade-offs. The next thing is to get to a prototype. The
Yeah.
next step.
Typically, the next step of the process would be a prototype. And again, the proof of concept is an early prototype.
Mhm.
After an initial proof of concept is done, the next iteration of the prototype, the goal of that would be to have it be a reasonable approximation of the finished product is going to be. So what do I mean by that? Again, things like the final packaging design. So the final plastic enclosure or metal enclosure, whatever it might be. Okay, it might not have that, but it would be done with custom designed hardware, whereas a proof of concept might be done with off the shelf development hardware as opposed to a custom circuit board. The next iteration would typically have custom circuit board. It would have all of the major components that are going to be part of the system. By major components, this is where things like, okay, if it's going to be battery powered, we may still not know exactly which battery, what size battery needs to go into it, but the prototype would still be battery powered to not battery powered so that we can test it and see what size battery are we going to end up needing. That first one should have all the functional pieces of the finished product and allow us to test out all of the ways that it would be used, how it would be powered, how it would be charged if it's rechargeable, how a user would interact with it. It should be something a user could interact with. This isn't an end user, but a person that can test it and validate, again, not just the core function, but now additional things like, is this, if it has maybe it has a display on it that's providing information to the user. Is the display bright enough, large enough? Is the text readable on the display? Those are all the types of things that we want to be checking at this prototype stage. And oftentimes of course, in the design process, we are aware of those requirements and we're considering them when we're selecting parts and things like that. But if I look at a part data sheet and it says, okay, this is a display and it's 240 pixels by 160 pixels and it's 2.3 inches wide and 1.9 inches tall, all of that information is there, but I can't necessarily visualize, okay, what does that mean when I put this image on it? What is a user actually going to see and how is that going to look? There comes a time when you evaluate everything that's available, but ultimately we've got to build it and test it and then put it in somebody's hands to see in reality how it works, what it looks like, what it's like to use. There is a lot of feedback that comes from that where you realize, okay, well, this display is not big enough. We need one bigger because we can't read this text or this isn't bright enough. These LEDs aren't bright enough to provide the indication that we want. Or when it's in this packaging and you're holding it in your hand, then you can't see that this indication because it's blocked by your finger or whatever it might be. And there's just many things that come out of that. After the proof of concept, the first full prototype is a big step because It is incorporating all of the things that should go into the final product. And technically, it is even, I would say, considered a candidate for final release. It almost never is the final release just
Mhm.
because inevitably there are things that you find as part of that process, but you have to start somewhere. Getting to that point earlier is preferable and allows the process to proceed quickly. So that is what we're trying to do. Get that initial prototype. Once we've done the proof of concept, get it in the client's hands so
Mhm.
they can start testing it, make sure that it meets their not only their functional requirements, but also just their vision for what the product should look like,
Mhm.
what the user experience should be. Those are different for every product. Oftentimes, because people think, I just want it easy to use, but easy to use means different things to different people and applications. Thinking about who the final user is, if easy to use is a general use consumer product, that's different than easy to use for maybe a technical tool that maybe, an electrician or somebody like that is going to use. Anyone else in different fields that might have some training, some experience. It depends on what the product is and
Mhm.
what it's doing, getting that initial prototype to the client so they can start evaluating it because they know best what that target market is for their products, what the users are going to want to do with it, how they're envisioning the users using it. That's the goal of that first full prototype.
Okay. And then for manufacturing, so if we get through all the prototyping efforts and making sure that, okay, this is going to work, now we just have to get it from the final prototype to, okay, this is how we're going to make a lot of these things. So how do we optimize for cost, manufacturability, reliability, that sort of thing? Can you talk about that? Got to make sure it's not too difficult to make a lot of them at a price that's going to give you some margins.
Design for manufacture is a key part of the design process. And it's often one that can be frustrating for clients because typically before that stage, you have a functional device. And when a lot of times clients say, okay, why didn't we design for manufacture from the beginning? And that's a good question. And we certainly, it informs the design process as we are going through, but there's a few reasons why there is a design for manufacture step at the end as well. One of those reasons is that in many cases, it depends on the manufacturer. A particular manufacturer will have specific capabilities and will want or may want certain things done in a particular way so that they can do end of line testing, so that they can manufacture at higher speed, so that they can do final assembly, whatever it might be. And a lot of that is manufacturer specific. And so it is, it's helpful to know who that manufacturer is going to be, and that typically is not really known until sort of the end of the process, and to work with that manufacturer on optimizing for their process, whatever it might be. And so that's one reason why. Another reason why we typically wait for this at the end is because in the course of the development process, things may change. Optimizing for a device with a 3-inch display doesn't make sense if we realize it needs a 4.5-inch display. Instead of the idea is to get to the end product, evaluate it for tweaks that we can make to this that don't affect the functionality, that don't meaningfully impact the form of it, but help with manufacturing. Things like arranging the circuit boards so they can be mounted in particular ways. It may be moving connectors around to different places because depending on what the product is, someone may be doing some final assembly and they've got to plug things in internally. And so making sure that's done in a way that facilitates ease for a user doing that assembly would be a DFM effort, right? That type of thing. And really working with the client, working with the manufacturer, figuring out how they want to test their product and making sure that we can design for test as well. That's what that step is really about, optimizing those things once the core features and function of the product have been designed.
So you mentioned testing and validation. So that's, what is that stuff like FCC, UL? I guess there's probably some functional testing. You gave the example earlier about something on a pet that's going to track where they're at. So I guess you would have to say, okay, how waterproof does this have to be? What kind of temperatures can it absorb once you have
Absolutely.
to? So you'd want to figure that out once you have an actual product. You come with this clever product. Labrador retriever jumps in the river, boom, it's done. The problematic, there's water resistant and waterproof, right?
Certainly testing is a key part of the development process. And there's a couple of aspects of testing. So the first is typically called validation testing. That is, does the product do what it's supposed to do? As part of that validation testing, you build a prototype or prototypes, maybe a small batch, maybe 20. It depends on what the product actually is. And then put it through a series of tests, testing all the important features, testing usability, making sure it does what it's supposed to do. That's one part of testing. Another part of testing is manufacturing testing. This is the step a manufacturer takes when they have assembled a new product. We designed it, we went through validation testing and said, yep, it does everything that it's supposed to do. Now the manufacturer is building it and they're going to build 5,000 of these things. And the last thing you want is 5,000 non-functional devices to show up. Right. So the idea is to build a test process that the manufacturer can do so that they can validate that they programmed their machines correctly, all parts are placed correctly, that all the different aspects of it in transitioning from a small onesie twosie prototype to building in quantity, that nothing was lost in that transition. And that when building in quantity, they can still build 5,000 functional usable devices. That end of line test is less involved because we already tested the functionality. It's more about, were parts placed properly on the board? Was everything soldered on correctly? Was everything plugged in where it was supposed to be? As it rolls off the line, does it do what it's supposed to do? There may be a quick functional test. Oftentimes the end of line tests are automated. The parts will come off the line and go into a tester. The tester will automatically run a certain amount of tests on the boards or the parts. And again, the idea being to ensure that what's being manufactured will function the way it's supposed to and the way the validation test showed that it would. And then the third aspect of testing is regulatory testing. FCC, UL, FDA, whatever, depends on the product, what regulatory regime is applicable. Making sure the device meets regulatory requirements is also testing that's done and has to be done with the candidate finished product. The regulatory portion is taken into account throughout the design process. At ES, we're familiar with the UL requirements. We're very familiar with FCC requirements. Some sort of industry-specific requirements we may not be familiar with. We would work with clients to understand what those are for a particular industry. If they have a regulatory body doing additional testing, the idea is to understand that early in the design process, but ultimately it has to get through testing with the final product.
Right. Now, I'll hear you work with medical device companies. So FDA, is that part of this?
Yes. So it certainly in many cases is part of that. And when we work with our clients to help them through that certification process and provides a technical expertise. In the case of FDA, it's primarily documentation they're looking for. There are clinical aspects, but the client typically does most of that. So if you come up with a new device, the client's going to have to set up clinical trials, and they're going to have to get people to put this device on that does whatever it is that it does. And they set up control groups, and they do all that stuff.
Right.
But as part of that, there is frequently technical documentation needs. And so that is where we will work with them to support those technical documentation needs, documenting the design, identifying critical components, documenting design choices and design iterations. All of those types of things are, in the case of the FDA specifically, are things that are typically part of the certification process there. Now, it's a little different for something like FCC. So just about every electronic device has to go through at least a basic FCC test. There is a basic radiated emissions test that is done and has to be done on every electronic product to make sure it is not radiating RF emissions that are going to interfere with other things. And so that test we do on just about everything. And sometimes the clients have set up the arrangements to do that, but there are a few different FCC test facilities and shops we work with. It's typically quick. The device only needs Part 15B testing. That's maybe a 4-hour at most a day tests over at the lab to set it up, run it through, and do that testing. And additional if devices have additional radios on them that are doing additional things, then sometimes there's more involved with the
Mhm.
FCC test. It just depends. We've worked with different test shops and had good success with completing that testing. We even have some limited in-house capabilities. We can't do certification, but we can do pre-certification. We have a Faraday chamber that we can put small devices in. They're not as big as the ones that are at test houses, but depending on the size of the product that we're testing, we can do that. We have a spectrum analyzer that we can look at it and see and identify, yes, this looks like it likely will pass, or no, this looks like it's got some issues and we need to figure out whether that's adding filtering or shielding or whatever it might be to address the radiated emissions.
All right, we're getting close to the end, so I'm going to ask you one last thing here. We talked about your manufacturer. We're imagining smaller outfits that they're not manufacturing, they don't have factories. But yeah, I'm sure you've worked for clients that do have factories. But so say that the client does need to get the thing made. Do you provide any help with sourcing a contract manufacturer? What's your potential assistance on that side?
So for sure, we worked with a wide range of contract manufacturers over the years, doing everything from circuit board assemblies and all the way up to companies that will do a full product assembly. They'll even put it in a box and put the instructions in there and put 5,000 of them on a pallet and ship the pallet somewhere. We have worked with a range of manufacturers, and we've worked with our clients working with their manufacturers as well to make sure that we provide the support that they need. So if a client has no idea where to start, we can certainly put them in contact with some appropriately scaled manufacturers. Obviously, someone who's looking to build 500 a year of something is different than someone who's looking to build 500,000 a year of a particular product. And so it is important to know what that is and what's an appropriate fit for clients. And then we can talk to them too about the idea of how much do you farm out versus how much do you do internally? We have clients that will say maybe the circuit board assembly is done by a contract manufacturer, but the final assembly of the product, they're planning to set up in their own facility and have their own sort of line set up, and that it's taking boards, putting them into enclosures, screwing things together, boxing them up, whatever it might be. In other cases, people are looking for full turnkey where they just want pallets of goods to show up and ready to go. We have worked with the full range of that and worked with clients across those needs. We can help clients meet whatever their particular need is.
Very good. So, Craig, anybody interested in getting a product from idea onto a shelf somewhere? It's probably got a really good idea of what the steps are involved. So, thanks you so much for your experienced insights. We'll stop there.
Sound good?